Hello, everyone. Welcome at my talk about Spring REST docs. I think we can start. All right, so Spring REST docs, new library from the Spring team, is there to help you document RESTful APIs, but using your tests. That's a new approach, which is really interesting. But first things first, who am I? I work for Ordina Belgium. I'm Andreas Evers. I really love open source, and I also contributed a bit to this Spring REST docs library. And at the moment, I'm actually working for Proximus as technical lead and coding architect. So actually documenting RESTful APIs is not that easy, not that straightforward, but there are some tools to help you out. And when you're actually setting out to select a tool for helping you do that, it's important to really keep in mind some ideas, some concepts, which are really important with actually documentation in general. So the first concept of idea is actually that having no documentation is better than having wrong documentation. So when you're actually documenting your contracts, it's very important that you have some assurance that your API is really up to date, that it's accurate. Because otherwise, people are not going to trust your documentation anymore, and they are not even going to read it. So it's very important that you keep it up to date. And if your tool helps you to do this, then that's just the first step in the right direction, right? Then the next thing is that documentation should be easy to write, and it should be in a format which is designed for writing. That's not that easy if you, for example, work with HTML. Then you got to work with all this verbose syntax. So using something like, for example, Markdown, which we do in our README files in GitHub, this really helps you along. So actually, Spring REST docs uses asciidoc for this, which is a nice format, which is similar to Markdown. Okay, and I don't really believe that you can generate almost everything for your documentation. I always think that there should be something which you still write manually, and for that, you need to have some kind of format, right? So the next thing to keep in mind is that I don't believe that frameworks should be analyzing your implementation to predict documentation. Okay, it's something that other tools do, but it's very hard to do this. And the chances that your documentation will eventually not be up to date or will not be accurate or not even correct is pretty big. It's very hard to predict what will be going on with your request and responses when you actually try to analyze your implementation details. So a tool which is actually doing this is Swagger. I think most of you know about Swagger. Is that right? Okay, that's a lot of people. And who actually uses Swagger in their project? Okay, a bit less. Okay, but for those people, this won't come as a surprise. This is a nice UI that Swagger actually provides. It's really useful if you like to be URI-centric in your documentation. So it actually puts the URIs first, and you can actually, by clicking on those URIs, discover which resources are available and what they expose, what information they expect, and what information they expose. Okay? So that's all nice, but it actually, when you actually want to go full REST, which is REST level 3, then you should think about hypermedia. So Swagger doesn't support hypermedia, and hypermedia is really the glory of REST. Are you guys familiar with hypermedia constraints? Okay, that's not that many. So there's this maturity model for REST where you can use these links to actually navigate from resource to resource. And that's the last step of the maturity model. And if you do this, then you're actually building something which made the web great. Because in the web, we have all these HTML pages, which are actually resources as well. And they have links inside and forms inside. And they actually perform like a get or a post on other resources. So they're like links. Okay, so this actually allows you to not having to bookmark every web page in the whole World Wide Web. And if you apply this to your API, your own API, you have two great benefits. The first one is that you have independent evolution, and the second one is that you have decoupled implementation. And those things are pretty important if you want to be able to evolve really easily. For example, I have here an example of such a hypermedia-enabled JSON response, which has two parts, really. So the first part is the data part, which you normally have, as usual, in your JSON, just a bunch of properties. And then you have these links, which are actually pointing to other resources. And this allows you to just have the keys of the links, the relationships, such as self, node, and tags, and not care about the URI itself, because you can just use JSON path to get that URI and then follow it. So if the server changes that URI, then you don't care. You're still going to work from a client point of view. Okay, so that's really useful. And if you apply this, then your tool, your documentation tool, should really be able to document this functionality. Because what you actually want to know if you use this is, what resource do I have? And from this resource, which links do I have? And when I follow those links, what am I going to find if I actually reach it? Okay, so unfortunately, Swagger doesn't support this by design. That's fair choice, because probably they're going to have to rewrite everything, but it's just not possible. So if you want to use hypermedia, you're going to have to look for another tool. Another thing about Swagger is that it's pretty intrusive in the production code. So it does use all these annotations that you have to put on your production code. And that's maybe like a nice design in theory, but if you look at this, then maybe you might not like that much anymore. And I've seen worse examples, actually. So you do have some JAX-RS annotations on top, but then you have a ton of annotations which are just documenting. And we already have all these annotations there. We really don't want more annotations, especially not for documentation. So this is something which we might want to avoid. And also, because of these annotations, it's actually trying to rely on implementation details. Like I already mentioned at the start of the session, it's pretty dangerous to do this. You just want to document your contract, and you don't want to document your implementation. This also allows you to just change your implementation, and as long as your contract doesn't change, your documentation is going to stay the same. It's pretty hard to actually do this if you like to rely on the implementation details, because, for example, if you have this these annotations, that's on the controller, but your response actually goes through maybe some filters or interceptors or even the HTTP client, and they could all do some changes to your response. So it's just very hard to do this, to get this right, and we actually see this by sometimes mistakes that Swagger has. For example, this one, it might be a bug that's already solved, but it's testament to how difficult this can be. We have this response entity body, which actually has inside status code, headers, and body. So that's not really part of the body, but okay. And then you have status codes with all these different status codes. And I'm sure that this API, this resource doesn't expose all these kind of status codes. Probably a couple of them, but not all those. And that's probably because the enum consists of all these status codes. But you don't really want to leak that into your documentation, what you wrote in your domain model, because that's separate. You should be documenting your contract instead. So aside from this, the framework is still heavy. Before August, it was about 31 megabytes, but then they removed the Scala runtime library, and now it's about half that size, but it's still pretty big. So for a documentation tool that really has to be like lean and mean, you don't want to have that big dependency, especially if you're going to build microservices, for example. Then you want to have small services and not drag all this extra libraries with that. So we should be looking at a new alternative, right? Because there are some downsides to Swagger, although it does have some pros as well. But if we could actually solve those downsides, we'd all be better off, right? So actually, Andy Wilkinson from the Spring team, he experienced these issues or these concerns firsthand when he actually used Swagger on a project. And he started out building a new approach, a new way of thinking, and implemented this by using integration tests. So when you're building integration tests, you can actually, for example, with mock-MVC, make requests and get responses back, do some assertions on that. And then there's also the possibility to with Spring REST docs, of course, to add some extra functionality, which will check if certain fields are there and if they are documented, and then also make that documentation itself. I'll just show an example right away. So once you've got these integration tests, they can be ran, and then once they're ran, you can actually get automated generated snippets, which are just serialized requests and responses, or some tables about what fields you have in the responses and all that kind of stuff. And that's all generated and guaranteed up to date. So once you've got that, you also want to have that manual documentation that I was talking about. So you're just creating a template which can actually state some more interesting information to the clients that you don't want to have automatically generated. It's just human language, basically, right? So that's the template, and you can actually insert these snippets in the template. Once you've done that, you can actually have your eventual HTML generated. And that's what you're going to send to your clients. That's your actual documentation. Okay, so now let's take a look at each of these steps and see how they look into the code. So we've got integration test. MockMVC, anyone familiar with this? I suppose most of you. It's just making a perform, so it's making a call on that URI, and then so the request is sent, the response comes back, it's checking if the status code is 200, then it's doing some more assertions with JSON path to see if certain fields are there. So that's all standards. That's what you would write when you were doing a regular integration test with MockMVC. And then you have this undo method, which is basically a hook that MockMVC provides to add extra functionality. And Spring REST docs offers that in the form of the document static method. This really allows you to add some link documentation, some response fields information, some request fields documentation, even more stuff, which I will show you later. And for each of the links, for example, you have to say, okay, which relationship, which key do they have, and what's the description. And that's the documentation. Okay, for the response fields, the same thing, which path, and then the description of this field. So the idea that actually is behind this to keep it accurate is that it will check if all these links are actually present in the response or these fields. So if a field is missing in the response but it's documented, it's going to fail the test. And it's the other way around as well. If a field is coming back in the response but you haven't got it documented yet, it will also fail the test. So this is the actual assurance that your documentation is always going to be up to date, because it will just not build. It won't even try to deploy this new form of documentation which is out of date. It will stop it. Okay, so that's the interesting part. So once you got this, it's also going to read these links parts and response fields parts. It's going to do this request and response, and it's making snippets, as I told you. So these snippets, for example, for requests, come in 2 different flavors, a curl flavor and basic HTTP notation flavor, which you can easily just copy-paste in a bash window and just reproduce it. For response, when you have a body, you see a body, which is also very concise notation. And as well for the links, which is a table. So that's asciidoc format. It's representing a table, but it's really easy to write. You don't have to mess around with table tags from HTML or whatever. And you can just see that it's like 2 different columns and then 3 rows which fill in this information. And this information is generated, and it's coming from that Fluent API, which I showed you in the first slide here. So as you can see, self no tags, and then this information next to it is the description, and that's just filled in here. Okay? So this is generated out of that. And then you've got the same for response fields, also the table. So once you've got these snippets, you have to inject them in a global template. And that's written like this. So you can see there's an anchor resources node and then the title node. Then you can fill in some manual documentation. Okay? You can really just describe it a bit. Also, the resource documentation, the resource the subscription or description really, isn't really going to change that often. So it's fine to document this manually. But what you don't want to manually document is which fields are coming back, which links are coming back, because this could change a lot. This could change often as well. So that's what actually we inject. We include them with those snippets. Okay, so that's always going to be up to date. Same goes for the other ones. So you can have the response fields, curl request, HTTP response. All these snippets are getting injected. So once we've got this template, we inject these snippets inside. we can just compile this into HTML, which asciidoc is doing for us. So this asciidoc is like a plugin in Maven or in Gradle, which just takes this as part of the build flow and will just generate these HTMLs. So here you can see it for Node. It's an example where you have these self-node tags, this table, which we had in asciidoc before. And the same for the other tables, and the curl snippet, and then this response snippet. So that's how it's really eventually looking. Okay, so that's the HTML that you want to give to your client. Okay, so aside from this standard flow, which is the basic functionality, there are also some extra features that are provided. So one of the features is that it's really easy to package the documentation in your product delivery. So this can be a jar file, a WAR file, EAR file, whatever, and you can really easily configure it that these HTMLs are packaged inside, so that when you deploy it, you also deploy, aside from your API, also the documentation, the HTMLs. Then there's also the possibility to do other snippets than the one we talked about. You've got the hypermedia links. So that one we saw already, the request and response payloads as well. But you can also document request parameters, path parameters, and HTTP headers, also in a similar way with kind of tables. So aside from this, it's also possible to customize the request and response before you're actually going to document it. That's sometimes required when you, for example, want to pretty print your response body or your request body before you're going to document, because that's easier to read. Or when you see, for example, some headers that you don't care about in your implementation, or in your documentation, I mean, and you just want to strip them off. So that's also possible to do. It's really easy with a Fluent API. Then it's also easy to add extra information to the snippets. So now we saw, for example, with fields, we saw the path of the field inside the response body. We also had dynamically added the type, which it can deduct. And then we also have description, which was the third column. But what about, for example, constraints? If a certain field can only have between 4 and 20 characters, we'd like to mention that as well. So that we can do as well by just using this extra information that we also put as part of that integration test documentation part. Okay, that's also with a Fluent API. So that's really easy to do. We can also ignore parts. So let's say something is coming back in the request, or in the response, something is coming back in the response body, and we don't care about a certain field, or we don't care about a header or something that's coming back. We can really ignore these parts. So it doesn't fail the build that way. Normally, if you don't have something documented, and it's actually coming back in the response body, let's say, then it will fail the build, but when you ignore them, it won't fail the build. It's pretty straightforward. And on the other way around, you can also mark parts as optional, so that it's just the other way around, where you have something coming back, or you have something in the documentation, and you don't have it coming back always. So maybe something which is only in a specific flow available, then you can say, okay, I'm not going to crash my build when this is not coming back in all the other cases. So we also support, well, this library supports JSON and also XML. So if you have response bodies or request bodies in XML, it's also supported. And there's support upcoming for REST assured, this is really nice, because not specifically about the REST assured tool, while it's a nice tool and it's nice to have it integrated, it will decouple Spring REST docs from Spring Mock MVC. So you can use it without it, really. And that's really nice, right? So that's coming up, probably in the next minor release, I would say. And there's one more feature, which is, it's not really a feature of the library itself, but you can use it for that. You can actually use these snippets, these request and response snippets, for stubbing purposes. So you can just, for example, have a wire mock server where you use these requests and responses as stubbing information. So if somebody's calling with the same request, then you can just return that snippet, that response snippet, and they just see this as a stub of the real API. But the real nice part of this is that it's always up to date. Just like it's for the documentation always up to date, these snippets are generated, and whenever you make a change to your API, you're going to have to change this documentation as well, or your build doesn't work. And therefore, those snippets will be changed, and as well, of course, the subbing solution. Okay, so that's pretty nice. Okay, so those are the features. Now I have a really short demo to show you the way this accuracy, this certainty of having accurate documentation actually works. Okay, so let me quickly. Can you guys see that? No. Let me just mirror these displays. Okay, great. So you can see this, right? Okay. So is it clear at the back as well? Good. Perfect. Okay. So we've got this car, right? It's in a Spring Boot application, by the way. Really nice tool. So we got a car which has an ID and a brand. This is the most simple Pojo you probably ever saw. So this car gets exposed in the API through the car controller, which is just doing a request mapping on cars. It uses JSON, well, actually uses HAL JSON, and it's exposing cars/ID, but also just cars by the default mapping. And there you can see that the car is being retrieved always with the ID that you ask for. It's really stupid, but at least it will show the idea. So it will also have a self-rel. This is the link, the hypermedia part. And for the cars, it has also embedded. I'll show you once we actually have it running. Okay, so that's basically the application. As it's Spring Boot, I can just run it by right-clicking the application, run as Spring Boot app. Okay, so it started on port 8080. I can check my, okay. So I can go to the cars/cars, and I get this back. It's not really nicely shown. Boom, boom, boom. Yeah, okay. But I suppose, can you see it? Okay, so there's links. Then we've got self-rel, which is this part, just the cars itself. And then embedded, you've got a car list with one car here. That's one car. And then links inside that car as well, because that's the self-rel itself for that car which is embedded. So I can just follow this link to that first car here. Okay? So this is what this hypermedia constraint is all about. I don't need to know the URI of the first car specifically. I'm just going to follow the self-rel of that first car, which is in this array. So I'm going to go to this. Okay? And now you can see I have a brand, which is BMW, and I get its self-rel back. So this is the resource which I'm going to change. Okay? So let's see how we write our documentation for this. Okay? So we've got this integration test here, which is just a lot of configuration up front. And then we've got this test, which just does should get car. There we do the perform with the mock MVC, a little bit like we saw that example in the slides. We just call cars the first one. We expect that we have a 200. And then we do this extra documentation. So we document it in the folder get car. We do this pretty print, which is this altering of the request before or the response before we document it. And then we will document some links, HAL links, because we use the HAL format. And the self-rel is actually the one that we want to document. We also have some response fields, which is the field brand, right? We saw that here, the brand, and then another field called _links. Okay, so this is working pretty straightforward. If we execute this, then it should run as usual. Green, I suppose. Yes, green. Perfect. So now my Maven configuration has this asciidoc plugin configured. So if I now run the full build, the Maven build for this whole project, then it should actually start generating the snippets and then also put it into this template. Yes, first let me show you the template. So the template looks like this. I have a bunch of top-level stuff. And then these anchors have some more information about the API in general that you want to document manually. For example, which verbs you can use, which status codes that are possible, then what is the hypermedia format or the constraints all about, because clients might not know this. And then we actually get to the resource part. So for the car, we just say the car resource is used to show cars available in the system. And we have a get part where we retrieve a car and a little description, and then we have all these snippets. Okay, the response fields, the response itself, and then links. Okay, so if I run this as a Maven install, there we go. Then, as you can see, it's going to do the test. Once it's done the test, it will actually start packaging it, and then it does the process asciidoc task, which will do this asciidoc merging. Okay, so let's take a look at what this generated. So here we've got in the target folder a couple of directories. We've got the generated snippets. In the car get, we've got the curl request. We've got the HTTP request. We've got the HTTP response. We've got the links and the response fields. Okay, this is just like in the slides. This is just generated out of these couple of lines that we added to our integration test. So then we need to merge these snippets with our template that we wrote. And from there, we actually get this here. So let me open this in the browser. Okay. All right, so this is what we got. This is all generated, okay? And you can see here that the car resource has these snippets injected. Okay, this is all because of those couple of lines that we added to the integration test. Now let's take a look at what happens when we change the production code, okay? So we can easily do that by just in the car adding a field. That would already invalidate our documentation. So let's add a field called type, okay? Get type, set type. Okay, simple. So then also in the controller, let's add some information about this type, car.setType, and then the type BMW type 320D, that one I heard? Okay, great. So let's just run this test first, okay? Because the test should already be failing. Okay, it's failing. Let's take a look what it says. It says the following parts of the payload were not documented. Type 320D, okay? So that just tells you that you forgot to document a certain field. Okay, so let's document that. In the test, we just use here type, and we actually call it the type of this car, okay? So let's see if our test is running. And yes, it's running, so let's now do the Maven install again to also get that process asciidoc task done. Yep, here it is. Okay, it's running nicely. So let's refresh. There it is, okay. So the type is now documented. So your build works and your documentation is up to date. So now let's do the other way around, that let's say we remove something from the car again. So this is pretty straightforward. We remove it again here. We, of course, change our controller as well. So here, let's continue now to load the test again. OK, it's failing again. And now the other message is fields with the following path were not found in the payload, the type. It's not found with the actual mock-MVC response. OK, so that's easy to fix, again, by just changing this. And of course, it's just rewinding, and it's going to work again. Okay, so that's basically the gist of it. There are also like headers that we can document, and these path variables, and these request parameters, all that stuff. And actually, if you want to see more samples, there are some projects which are in the GitHub repository, which give you all the possibilities that this actually can do. So if we just check here again, okay, it's back to the old one. Okay, so I think that's it for me. I hope this inspired you to give this tool a chance. It's a really nice approach, I believe, but it's still also evolving. While it's already mature enough for us, in Proximus, for example, we use this all over the place, and it's really giving us great value. So definitely check out the projects page and the GitHub page, and if you like some features added to this, Andy Wilkinson is really a great guy. Even if you do pull requests, he is giving great code reviews, so definitely worth a shot. Okay, so if there are any questions, yes?
Does it support the localization?
The localization.
Yeah, many language options.
That's a good question. I think there is a possibility to do this, although I'm not entirely sure. Um, Yeah, I'll get back to you on that, but I'm not sure. I know that for example, constraints, you can add more constraint information. For that, you can have property files, where you can have one for each language, of course. So that's possible, but for those fields in the integration test itself, I'd really have to check that. But I suppose if it's not there, it can definitely be a good suggestion for an extra feature. And I don't suppose this is too hard to implement if it's not there. Okay, but I'll definitely let you know on Twitter. Any more questions? Yes?
Easy for testing.
Is it?
Easy for testing, like Swagger, you can just put in some XML and test the get call. Can you do the same with RESTdoc?
RESTdoc is just a documentation. So it doesn't allow you to test against it unless you use it as a stubbing solution. And then you can probably just, I mean, if you combine it with WireMock, you can call it. But there's also no feature to generate your code from Swagger. You can generate the client, right? That's not there, which is not the design of it. But if you combine it with WireMock, then you can test against it. So that's easy, right? I hope that answers the questions. Okay. All right, that's my time. Thanks everyone for coming over.